Welcome to Junior Einsteins Science Club, and congratulations on being here today. We are so delighted to let you know that because you're here today, you are all now officially Junior Einsteins. Today we have a fantastic science club set up for you. It's called Forensic Crime Scene. And it's not too scary, you don't have to worry. It's just teaching you how scientists can look for clues to help solve crimes. So, forensic science is the application of science to the law. So the crime scene investigator or the crime scene examiner is not a scientist and is not a policeman or woman, but they are the person who goes into a crime. Let's say there was a burglary or some other crime that happened, and they go in and they look for all of the clues that a detective would look for, and then they put all the information together and they tell the scientist and then they tell the police, so that the crime can be solved, hopefully. And what do they do and what do they find at a crime scene? So the main things they're looking for are clues, like a detective would, but they're looking for things like blood, bodily fluids like saliva, hair, pieces of fibre. They're looking for fingerprints, shoe prints. They're looking for tools. For a forensic crime scene examiner, it's really important that when they see a crime that's happened and they're going in, they have to be really careful that they don't leave their own fingerprints, that they don't sneeze and leave their own saliva and DNA in the crime scene, because then maybe the police would think they did it. So you have to be really careful about that. They also have to be careful about what they walk on, because we sometimes look for footprints of a criminal or a robber. And if the scientist or the crime scene examiner walks all over everything and leaves their own footprints, they're messing up and ruining all the evidence and all the clues of the crime for the scientists and the police. So they're always very, very careful. So the crime scene examiner will go in, and we've set up some clues here, some really, really fun clues today. So the crime scene examiner will go in and they will take photographs, they will take videos, they will take even drawings and rubbings, and they'll collect loads and loads of clues. And today we're going to talk about all the different clues we're going to collect from a crime scene. Now, there was a very, very famous man called Professor Lockhart, and he was professor of forensic medicine back in 1910. And he was the one who really thought about setting up forensic science as a science. And what he said is really important. He said, every contact leaves a trace. So if a robber or a burglar goes into a house to rob things, everything they touch will leave a trace. They might drop a hair, they might leave their fingerprints, their footprints, they might knock something over, they might use a tool to break into a door or window, and this would mean that they leave marks on the door or window. But also, when they're finished robbing something from the house, they take away evidence with them. Maybe they take away a little bit of hair from an animal that lived in a house, or a little bit of fibre, like wool from a carpet. And the scientists and the police and the crime scene examiner can take all this information and find out who did the crime. So, DNA. You've probably all heard about DNA. It's deoxyribonucleic acid. You don't need to know that word, you can just call it DNA. But DNA is in every cell in your body, and it's inside something called a chromosome. It's really, really tiny. And you get half your DNA from one parent and half your DNA from the other parent. So everything that DNA does, it's like it codes you to give information about how you should look and how you are as a person. So if we go back to the forensic crime scene and we start thinking about how would we find out who was the robber, how would we find their DNA? So the first simple way of looking for DNA is to look for blood. So the robber might not have left blood behind, but he might have cut his finger when he was trying to break into the window to get into the house. Or he might have left his chewing gum and he has some saliva and DNA on his chewing gum. Or he might have left a piece of hair. So we're going to look first at how the crime scene examiner and then the forensic scientists would figure out about whose blood it is at the crime scene. So crime scene examiners use these fantastic things called black lights. And the interesting thing is that even if somebody cut their finger and dropped a little bit of blood and then they cleaned it up, the black light could still find that blood. So that's why it's really super tool to use. So when we turn it on, it's sort of purpley. And if we go over here, imagine that I've put some blood here and I've used something different and scientific, but pretend that it's a bit of blood here. And when you move the black light across, you can see that it glows because bodily fluids absorb all of this light and then they reflect back this fluorescent type of light. So it means we can really see all the tiny drops so well. So that is a really, really useful tool. And if the forensic scientists and crime scene examiners use this, then they can find the blood, and then they use the scientific tools to take that, look at it under the microscope, put it into machines, find out whose DNA it is, and then they can catch the robber, which is the main plan. Another really, really fun and interesting way that you could do at home is you could start to think about setting up a pretend crime scene and what you'd leave behind. And one of the things you can use that's easy is this, hair. So I don't know anyone around here who has long black hair, do you? But if they left this at the crime scene, the scientists and the crime scene examiner would take this. They would put it very carefully. They would take it with the tweezers and they would put it in a bag and they would put a lot of details, bring it back to the lab, look at it under the microscope. And you can tell a lot from the hair. You can tell if it's hair from the head or from an eyebrow maybe. You can tell if it's dyed or not. You can tell from how long it is and how thick it is, whether it's curly or straight, which person this came from. And if the hair has a little root on the end of it, there's DNA in there as well. So that's an interesting one. Another really important crime scene tool, which is a combination of DNA and just using your observation, is this. Now, when I talked about the robber maybe spitting out some chewing gum and leaving his DNA in it, imagine if he did something really, he or she did something really, really bad and silly, like brought an apple along in his pocket and took a bite of his apple, and then the apple fell on the floor and he left behind his teeth marks. So if there's teeth marks left behind on an apple like this, first we would try to get some DNA from the teeth marks because of the saliva. But secondly, what we would do is we take something like a clay and make a mold of the teeth marks. So you take the clay, which is all smooth, and you would push it down onto the bite mark. And if you push it down really well, and this is done very professionally by the crime scene examiners, and when you take this off, you can actually see the teeth marks there. So what you would do then is take these teeth marks, make a mold like plaster of Paris, and you'd have a perfect outline of the robber's teeth. And then you can bring them to a forensic dentist, a dentist that does all of this all the time to find out whose teeth marks made the bites. And they then have a database where they keep all of the information, and everybody's been to the dentist at some point, or most people have. So this is how they start the detective work. figuring out how they can match these tooth marks to the robber. So if you think about a robber, a burglar, a baddie breaking into your school or your house, they would come in a window or a door, but they'd probably have to try to get in using like a screwdriver or an axe or some kind of tool to either get in the lock of the door or to break open part of the window. And forensic crime scene examiners find this really useful, because if you imagine that a bad guy is using a tool to try and open a lock, they'll leave lots of scratches, right? They'll leave lots of marks. So imagine this is a lock and they're trying to get in that keyhole, but they're leaving lots and lots of marks. Or it's a window and they're trying to break open that window with a tool. They leave so many marks on the surface of the wood or on the key, on the lock, that what the forensic crime scene examiners do is, again, take a little bit of material like this and take a mold of it. So they put it on, and all this is to find out, because the robber, the baddie, probably took the tool away with him. Now, he might have been really stupid and left it there with his fingerprints on it, which is also useful, but if he took it away with him, we don't know what that tool is. So we need to find every clue possible to try and find this robber. So you take a mold like this, and when you look at it, you can see the markings here, which are really, really useful for the forensic scientists to look at. And the forensic scientists, again, have a huge database of what does it look like when it's a screwdriver or a scissors or an axe or a knife. And they're really experts at this, and they set up a whole area and they do practices and they see what it fits. And then they might be able to say, hey, he used a scissors and afterwards took it with him, but we know what type of scissors it was, and we know they're sold only in one shop in the town, and maybe we should go into that shop and see if someone bought one recently. And they start to think like a detective. So you start off thinking like a scientist, and then you move on to thinking like a detective, and all these clues are going to help us to catch the bad guys. So the other thing that I talked about when I talked about Lockhart's principle, that every contact leaves a trace, it means that the marks are left, maybe the blood is left, or the saliva on the chewing gum, but also maybe a little bit of carpet got attached to the bottom of the shoe of the burglar. And if that happened, and then we eventually find the burglar, maybe through fingerprints or DNA, we'll be able to definitely look on his bottom of his shoes and see if we can find something that he took away from the crime scene. So the other thing that the forensic crime scene examiner can look for, if a gun is used, they can look for details about the bullets. And so imagine that there was a bullet hole in a wall. They bring in somebody called a ballistics expert, and the ballistics expert can look at the hole in the wall and figure out, using a lot of mathematical calculations, where the person was standing when they shot the bullet into the wall. And this is important because it can give us lots and lots of clues about the crime scene. So we talked a lot about fingerprints, but now I'm going to tell you a little bit more about fingerprints. So everyone look at your finger. And I mean, if you move it around a little bit in the light, you'll see that there's lots of little marks on your finger, and that's your fingerprint. Everyone has fingerprints. Everyone's fingerprints are different. But your fingerprints, you leave them everywhere. So when you pick up a glass or when you touch anything, you're often leaving fingerprints behind. Even if you touch a piece of paper and it doesn't look like you've left a fingerprint behind, a forensic crime scene examiner can look at that really carefully with specialized equipment and probably find the fingerprint. So your fingerprints are really sort of beautiful if you look at them. And this is a giant fingerprint. And it is showing you all of the types of patterns in a fingerprint. So the three main patterns that we look for is a loop. So that would be a loop there, like that's just looping around. Then there's a whorl, and a whorl is this, whorl there. And then an arch. So arches are these ones up here. So everyone has a unique fingerprint, and you have pores in your fingers, and even when you're not hot and sweating, there's still a little bit of moisture, still a little bit of sweat coming out of your pores. And now in that sweat is your DNA as well. But the fingerprint is really important because it was actually about 1,000 years ago that the Chinese realized that everyone had different fingerprints. And then it was a German man, Mr. Mayer, who actually suddenly realized that all fingerprints are unique and we should actually make a database and keep all of the fingerprint records of, particularly of criminals. There's a really famous case of a man in 1902, and his name was Harry Jackson. And it was the very first time anyone was put in jail using fingerprints, because Harry Jackson broke into a house and he stole billiard balls, which are balls for playing snooker or pool. And he said he didn't do it, but he dropped one of the balls on the way out of the window, and they took fingerprints from it. And this was in 1902, so it was the very first time they were really doing this. And they matched the fingerprints to Harry Jackson, and he went to jail for 7 years. So a bit harsh, but that's what happened. And there was another man called John Toms who was caught because the edge of a piece of paper that he had used was found in his pocket with his fingerprints on it, and his fingerprints were also on the paper and on the gun that he'd used on a crime. So they were the first two times, the main times that fingerprints were used and started to become famous, because before they were using fingerprints a lot, they were using a very interesting way of looking at criminals and trying to figure out who was committing crimes by taking measurements of their head and their nose and their mouth, and they're writing down all these measurements, and then they were using this to catch criminals, because criminals would use disguises like wigs or dyeing their hair or growing a beard. So when a criminal was caught, they'd take all of these measurements of the height and the size of the hands and everything. But when you're using all of those things to catch a criminal, they're not precise enough, they're not perfect enough to know that they really did the crime. But fingerprints are perfect enough to know who did the crime. So now I'm going to show you how the crime scene examiner and the detectives in the police would dust for fingerprints. So I take my brush and some fingerprint powder, and I dust on this glass all around. And you can see that when I move this in the light, I can see some fingerprints quite clearly, especially under the powder. So the next thing that the detectives do, and the crime scene examiners, is to take a bit of tape, just like this, just like sellotape, and they put it down like this to get a really nice fingerprint impression. So the fingerprint impression would then go in under the microscope to be looked at, and then it would go into the fingerprint database and see if we can match it up with someone who committed a crime before, because the police would have their fingerprints on the database. Fingerprints also work really, you can see it dusted here. If I dust for fingerprints on a CD, it works really well, because these are surfaces that take the moisture really easily. But if this fingerprint was on paper, this would be much harder to do. So here is an example of the fingerprint being dusted with the fingerprint powder, and then you see the fingerprint impression here. So that's very useful for the police and the forensic scientists. So, how do we match the fingerprints up? So I'm sure you've seen before on television somebody having their fingerprints taken. So I'm definitely not a criminal, I'll just let you know, but I'm going to have my fingerprints taken today. So I have a little fingerprint card here, and this is from our Junior Einsteins Science Club when we do crime scene forensic sessions with our Science Club children. And what you do, and I won't do all my fingers, see I did a practice one earlier, is you have to roll your finger on the ink. This is ink, and you get a nice blob of ink on your finger, and then I'm going to gently roll my finger onto the first one here, and each box is for a different finger, and you can see really clearly there the perfect outline of a fingerprint. And this is how we keep a record of people who've been bad before, and then if they're bad again, we can catch them more easily. So I talked earlier about the criminal maybe leaving behind footprints. So if a criminal was outside the window trying to break in and it was really muddy outside, they might leave really clear, perfect footprints. But if it's not muddy and wet outside, maybe their shoes are a tiny bit dirty, and they might leave a little shoe print like this. See, this is a bit of a dirty shoe here, and when somebody walks and then walks away and then walks again, you can see that there's an outline here. There's an outline of what the bottom of the shoe looks like. So that's really interesting. Even if somebody was walking on a nice clean floor with nice clean shoes, the forensic crime scene examiners could still use special equipment and lighting, going sideways on the floor and shining special torches and lights, and get a really, really good picture with really special cameras of a shoe print. Now, the reason that we care about shoe prints is because there's a lot you can tell from a shoe print. You can tell maybe what type of shoe it is. You can tell maybe where these shoes were bought, and then go and look and find out if you can look on the CCTV and see where the criminal bought their shoes. But most interestingly, you can tell a lot about the prints on the ground outside the window in the grass. You can tell maybe how heavy that person was, whether they were a man or a woman, by the size of their shoe. The type of shoe it was. Was it a lady's shoe with a big heel on it, or was it a big, huge boot? So we can get a lot of information from this. And I brought a picture to show you of a shoe print that's outdoors in the mud. And you can see that this shoe print outdoors in the mud is quite deep, and clearly you can see the marks on the bottom of the shoe. And then this one is one that's seen underneath a special light. And if you didn't have the special light on this, you wouldn't see that shoe print on the floor at all. So that's a really interesting one. So what we do in Science Club with all of the Science Club Junior Einsteins is we get everyone to take off their shoe, and we get them to do a quick rubbing of their shoe. And the way you do a rubbing of a shoe is like this. You just put the paper on your shoe, and you take your pencil or a crayon or anything you have nearby, and you rub this really, really across the whole bottom of your shoe, and you'll see that a pattern starts to emerge, and then you can see that each shoe pattern on the bottom is quite different, unless you've all got the same shoes. So this is a rubbing of a shoe rubbing, and this can be used to compare with the actual footprint that we found at the crime scene, and then you know what type of shoe it is, and you know all that information about the potential criminal. So I think that I've told you a lot today. I've only told you a tiny bit about how crime scene examiners work with the police and with forensic scientists, but I hope it's given you a good idea of how we can use science to solve crimes, and I hope you had fun. And well done for being Junior Einstein.